Hello folks, and good evening, or good morning, good day, or good afternoon, whichever you may prefer. I know I've gotten some flack for getting that wrong in the past, so there you go. Today we will be taking a look at the thing that arrived here yesterday. It is, as you can see, Facit, using what I believe to be a very nice, almost space age logo, which is appropriate because I believe this thing is early 70s something. But without further ado, let's take a look at it. I'm sure you already have a good idea what it might be. And right you were. This is a very early electrical calculator. It's not mechanical, has very few, if any, moving parts. It's simple enough to the point where it only does fixed point arithmetic, has 0 to 6 decimal places, set with this knob here, and it has just 10 keyboard, or 10 key keyboard, clear buttons, subtraction, multiplication, division, and this button is actually used for addition too. It also has a very neat feature that I think sets it apart from most other calculators of its type, which I will show to you now by powering it on. The display. This is not an LCD, it's not an LED or anything else that you might come up with. This is actually a vacuum fluorescent tube display, or as it's commonly referred to, an Itron display. It's, as you can see here, if I adjust there we go. As you can see, it's currently full of utter rubbish. This is because this calculator is early enough to the point where it does not care who might judge it for what it's doing. So the memory starts out full of rubbish. Let's get rid of this. Like so. Then we can do some simple additions. So let's have a look. Just 25 plus 36 plus 48 plus 7, 65 minus 4. Now the minus key, interesting. So it actually only subtracts now. I wonder, by blank pressing I go back into the addition mode. We're discovering this thing together, you and I, because I have not used it very much either. Now, it does the common calculator things. It does multiplication too, as you can see from this big button here. And just, let's do the simplest thing. We can do the number of seconds in a year. So 60 seconds in 60 minutes. Oh, sorry. 60 seconds in 60 minutes in 24 hours in 365 days. Now, here we go. We have 31,536,000 seconds in a year. Unless it's a leap year, of course, in which case we need to add a fair few more seconds. I believe it to be 3,600 more in a leap year, if I'm not mistaken. Now, as you can see here, the Itron display has a particular speciality, I would say, wherein, as you can see, the zeros are all half length, and the reason for that is actually very simple. You see, these early calculators, they did not know how to do leading zero suppression, which means that, as you can see, even though these zeros are all in the front, or sorry, they're ahead of the number, they're not actually switched off as they would be on a modern calculator. So, by setting them to half length, you actually improve the readability of the display significantly. You probably also noticed another thing with this calculator. It does not do suppression of the screen when performing calculations. So, as you likely saw, let's take 31,930 times 12. Now, watch what happens when I push the equal sign. It will do whoop, and it becomes 383,160. Very neat. So, with that in mind, let's look at some other features of this thing. For instance, it has a switch here that sets what happens when I push the equals key. I can have it do continuous divisions, do nothing, or additions, or subtractions, or multiplications. Multiplications is useful in case you wish to calculate a square of something, or a cube, or whatever. So I take 2 times 2, so 2 to the power of 2, 4, 2 to the power of 3, 8, to the power of 4, to the power of 5, to the power of 6, to the power of 7, and to the power of 8. Of course, I can do the same with division. To the power of 8, by 2, 7, 6, 5, 4, 3, 2, 1, 0. Other features being the floating point decimals, terribly sorry again, fixed point decimals. While this is certainly a remarkable machine, it's not yet there. So, for decimals, I have now set it to 6 decimal places. I will do an approximation of pi that we've seen earlier. So, 355 divided by 113. And now watch this. Boom. 3.141592. And as you can see, the screen just dances at the prospect of getting to do some math. Entirely unlike myself in my high school years. Now let's see if I can get the... I've taken to using manual focus in these videos because otherwise the camera is terribly liable to focus on my hands. Now let's do some sort of large division. Let's do 9, 8, 7, 5, 4, 1, 2, 3, 4, 5, 6 divided by 7, 8, 3, 7, 5, 4, 2. And let's do the division. Let's see if it keeps working for a while now. No, it actually keeps working for less now. How strange. Especially since it only wound up creating 1 decimal place there. I wonder why that might be. 1, 2, 3, 4, 5, 6 divided by 0.614. I really can't tell if that's... oh yes, of course, it would be a number below 1, since the latter one was a larger number. Makes sense. So we clear that. And set the number of decimals back to 0. Do 8 plus... Oh! Here's an interesting thing. Do you remember the repetition switch we mentioned earlier? Now I actually had it set to division and it attempted to divide by 0, I believe. Not so good. Let's switch it back and try again. 5, 6 plus 68 plus 9. And there you have it. Regular addition, subtraction, etc. So, on that note, I think I will have to thank you for watching. And, oh boy, it's almost 12 minutes. Well, it's been fun, I hope. Hope you enjoyed your time here. Bye bye for now.